Yo, 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 let's start there. Good morning, Fabric, by the way. Fabric, how was your weekend, Mr. I don't have time to stream? It was good. Was at a wedding. That was nice. How about you, Fabric? How about you? Although I seem to have gotten a cold now, so we will see how this goes, but yeah. Okay, been a while, and it's still fluid here. In the process of optimizing it and cleaning it up. Okay. More specifically, this one here. Okay, I get it. Great, nice to hear. And that explains your voice. Yeah. Yeah. Something is up, but it's not too bad. So, when we calculate minima here, yeah, we need a height difference, and we're gonna do these comparisons again. I'm talking about these. So this one is pretty much the same as this one, I think. And this one is pretty much the same as this one. And I don't want to do these comparisons twice. We pretty much want to bake them into just once and solve both things at once. So can I do this in a nice way? Yo, what's up, Derek? Because what we want to do here is, let's see here. I don't know if I want to name them like this, but let's do something like this. Is lowest point. We're gonna do true, and bool has taller neighbor. Doesn't quite sound right, but I wonder if we want to do. Okay. Let's do can move down, false, and can move up. False. And what we want to check here is if p height is bigger than n height, can move down is equal to true. And what is the second one I want to do? Else if n height is bigger than p height, can move up. Is this what I want to do? And then in the end, we basically want to do, the logic is this, I think. Bool is minima is equal to not can move down and can move up. This is basically how we calculate minima. We can't exit early this time around. So previously, as soon as this one became true, we exited the for loops, but now we're combining the minima calculation with the fluid spread. And I'm gonna try and combine it even more, actually. So if P has a neighbor that has a smaller height, can move down is true. And if P has a neighbor that has a higher height, can move up is true. And yeah, okay. The thing is, this comparison here and this comparison here are also done within this one. More specifically here. And I don't want to have it like that. I want to do, like when we do this one, I want to set can move down. And when we do this one, I want to set can move up. Probably gonna rename these as well. But yeah, so now maybe having this one as a method. Like during the full course of the algorithm, we're gonna call this one multiple times. I don't want to repeat the code every time. And I think this is the only time we're gonna calculate minimas. I think. I don't know if it's that big of a deal, actually. But we might as well do this and use height difference instead. So if this one is bigger than 0, smaller than 0. And we're gonna rename this one has lower neighbor. Has higher. Yeah, and then we know that it's a minima, but I think we can... I don't think we need this boolean here. Instead, we're just gonna do if this is true, we want to add it to I think we want to add it to final points. I'm just gonna add one of these to clarify what is actually included here. So now back to the question as well. Do we want to reorder this one at the end here, or do we actually want to add it in the correct place? And we ordered them by finding minimum fluid amount. So fluid amount they have. Do we have... Yeah, I want to do order by C# insert in list at correct position. I don't know. Like, can we add... Okay, we have index, but... Ascending. Yeah, I want to sort it in descending, I would say. Maybe that doesn't matter. Okay, so get the index and then we just use insert. Binary search. Okay, beautiful. Yo, what's up, Contra Dash? Haven't been here in a while. Terrain come along well. Yeah, I would say so. I would say so. Currently in the process of adding water to it. And yeah, it's summertime, so it's moving slowly forward. Binary search. Okay, basically, so what we want to do is, assuming your list is already sorted in ascending order, so bigger and bigger and bigger, I wonder if we could go that way as well. It's okay. So instead we do last, move at okay, so we sort it in ascending, and then we want to add it at the last point. Conrad Dash, love to hear that. Nice. Yeah, hopefully I will be able to do some videos about it this autumn, but we'll see, we'll see. So here we want to use this very nice binary search, and I wonder if we can do it like this. So we do unvisited points, binary search, and I wonder if we can do do something like this, and then we do UP dot terrain patch terrain data water temporary Conrad Robin's devlog better than the Super Bowl. I don't know about that, but I appreciate it. I appreciate it. Yo, good morning, Wesley. I would have hoped that I could do something like this. So I want to do a binary search, and I want to do it on this value. Basically. Although I wonder... this one should be instant. We're pretty much just reading a raw texture data, or constant, I would say. Binary search, let's see here. For an element. Do we have an example with a comparer? Are we really gonna have to implement this one? I don't know about this. So basically we would have to implement a comparer. Instead of string we would use tuple, because I want to avoid... fucking hell. Wonder if we're gonna do... We're gonna do it like this instead. And unvisited points, new. So I wonder if we want to do, instead of having to do unvisited points, do we need to do that? Let's see. Fluid solver, yeah we do. So instead of having to do this one every time, we could probably do ordered. Could we do something like this? Just to be able to skip this one. Yo, what's up, Lima? Is it hard? I mean, to do coding. Looks complicated. Sometimes, and sometimes not, I would say. So, what can we replace, remove at, and add? Do we have? We probably can't, right? I don't know. Yeah, you would have to do... I'm gonna double check one thing here later on as well, but okay, let's hear. I think we're gonna have to do take, right? Take last. I don't know if this is worth it, as opposed to just cast it to a list after ordering it. Okay, so instead of add, we can do append. Here we take the first one, that's good, and then you do... So instead of doing remove at, we just do unvisited points is equal to unvisited points dot take. And then we take count is not a positive number, this method returns an empty. And well, that's pretty good. So dot take last, right? And we want to take unvisited points dot count -1. Hey, what's up, Dungus? Good luck with your game. Thank you, appreciate it. Okay, so this would pretty much be the same, right? It's just that when it comes to unvisited points, we work with a IEnumerable. IEnumerable. Ordering it. I wonder. Okay, I wanna visualize this one now. So we're gonna add we're pretty much just gonna take the previous visualization method we have and add it once again. See what we get. But water temporary. I'm starting to dread the fact that we might not be... So we do the first step of the algorithm, put the result of it in water temporary. Then we have water previous as well. That's pretty good. So we do the first step of the algorithm, put the result in water temporary. Then we pretty much want to do we need a 3 here? Yeah, then we pretty much want to add this one to okay, so the flow we will have when we add water to any point in the terrain will pretty much be this. We move whatever we have in water to water previous. We do the first step of the algorithm, put the result in water temporary. Then we take whatever we have here and add it to water. And we need to get in timestamp as well, because we want to do a nice animation between previous water state and new water state. But when we have added this one, or added this one to this one, that's when we start step 2 of the algorithm, which uses this one again to calculate the final result of the water. It might be doable, probably gonna be very hard. But then again, exactly how we solve this, or exactly how we implement the solve, we can wait a bit with that. It's not that important. What we only need to focus on now is that when we do a step of the fluid solver, we put it in water temporary, and between each step of the fluid solver we take whatever we have here and put it in here, so that this one is clear every time we start a new step of the algorithm. Yeah, I think that's it. But let's see. Improvement, possible improvement, possible improvement. Also possible improvement. Okay, but this is the first step at least. So let's implement a private how do I want to visualize it this time around? Previously we did it with game object boxes. I think we're gonna skip that one right now. Instead we're gonna do... Should I start visualizing it with... Yo, what's up, Namida? Good morning, good morning. I'm just pondering if I think we're gonna do it like this. When we're gonna start, when it's time to finally start experimenting with animating through shaders, we're gonna rely on this method, but for now I think we're just gonna go with boxes, honestly. And this time around we're gonna do, let's see here, where do we have this one? Terraform. Is it in Action Terraform? Yeah, it is. And basically, so between each step of the algorithm, we want to do this, and then we want to do visualize state with boxes. I guess we can do it like this. Okay, so now to the question how exactly this one should be done. So in the previous iteration of this fluid solver, we just spawned boxes as we went. I don't want to do this time around because I don't want the instantiation of visualization objects to affect the actual timing of the algorithm itself. So we pretty much just want to do like this when we don't measure the time. The problem with this, however, is that we're gonna alter the water temperature data for points that might not be in the final lists. So yeah, final points finds the minimas in the first algorithm step, or rather this one contains all the minimas after the first step. I think, however, just visualizing those is not enough. I want to visualize more things. So I wonder... wonder. The fact is that we have the data we want in the textures. Do I have to worry about this? No, I don't think we do. I guess it depends on these, but we should not have to worry about it. I guess we could do it like this. Terrain patch start, X start, Y start. I think we're gonna do it like this. It's not gonna be pretty, but visualize current state with boxes, and then we want to do or actually for each we do it like this. Maybe not distinct, but something similar. Distinct by, probably. Ooh, we don't have that one in this version. Okay, that sucks. Point. Okay. Oh yeah, we do, instead we do points, dot select many, p dot terrain patch, select and distinct. That's how we want to do it, right? So for each point, get all the terrain patches, remove duplicates. So now we have a list of terrain patches. Like, this one doesn't need to be quick. We just need to make sure that we visualize all the relative points. So now we have all terrain patches. We have all relative terrain patches. So all terrain patches that has been involved, I guess. Okay, so not really though, but we have all terrain patches that contains a minima from the first step of this algorithm. So we might actually get, we might actually miss out on some terrain patches that still has water temporary that has been changed, but we're not going to visualize it. am I okay with that? I don't know. Probably not. Like what I'm trying to do here is, like, it's not hard in any way. It's just I'm trying to do it in such a way that we do not affect the actual core of the algorithm. So one could think that we added a second list of visited nodes and use that one here, but I don't want to add more logic here just to be able to visualize it. I want this one to be as clean as possible. I guess we could also add fluid. Guess we could do terrain. I have to check this one first. Terrain base. Terrain patches private. Set the bug mode. Yeah, we could do it like this. Terrain. Data visualizer. Why not? What? Ah, that one is... I'm pretty sure that's not the case. Okay, that explains it. Instantiate fluid amount, color. And can we do it like this? Hopefully we can. And then we do 4. Ooh. Ah, never mind. Oh yeah, set. Set might be a little bit more costly than I initially thought, but it should be okay. Habuka, what's up, by the way? Yeah, I think we're just gonna visualize it like this. So... depends, actually. Boo, 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 boo. Habuka, how's it going? It's going... Yeah, it's going pretty good, I would say. It's complicated, but we're moving forward at least. Yeah, I wonder if I want to do this one first of all. Float value is equal to this one, and if value is equal to 0, continue. We don't care about visualizing data points that has a value of 0. No point. Okay, so with these here, we can probably do... So when the first step is done, we do terrain base dot clear terrain data visualizers and dot visualize terrain data water temporary. What's this for? Dynamic terrain? Question mark. Yeah, close. So we have this terrain that the player will be able to terraform in different ways, and currently we're working on the water solution. So how the water should behave and how it should visualize. So even more specifically, right now we're working on the fluid solver. So adding water at point X, how will the water spread? Yeah, that's what we do. We have a solution in place, but it's extremely dirty and unoptimized, and we're currently in the process of rewriting it in a better way, and then we're gonna time it and see what decisions we have to make based on the timing, because I do want the player to be able to add water in real time, but depending on the results of the timings, we might have to get more or less creative on how we show it. So, let's see. Yeah, we do it like this. We just held terrain base that visualize this terrain data type now. And that should be about it. we're gonna have to do some additional setup before we can test it. And I also... Unvisited point. We take last... Will this one ever... I'm always a little bit afraid that I'm missing something when we have something like this. So worst case scenario, this is never false and we get stuck here. But I'm pretty sure that won't be the case here. Or I hope at least. So environment, yeah, we have a fluid solver here, which is our old solution. We're gonna keep that one, but we're also gonna add terrain fluids. That's not how we're gonna do it. Terrain base. Maybe. Yeah, I want to generalize this one. anything else we need to do? Yeah, I'm still a little bit... The entry point for our terraform this time around. Yeah, right now it's pretty much done in such a way that terrain base needs to be the entry point. I'm just not too sure about that decision. For the debug visualizations to work, we need it to be that way though. Or... if we want to do debugging, I might as well go environment controller, terrain, fuck yeah. So we might as well do terrain, fluid solver. We don't need to send this one in, and instead we're just gonna do... still... Oh yeah, that's true. That's true. It's not a mono behavior, so we might get away with this one. But we need to do... yeah, this is how we want to do it. So terrain base will not have this one, but an environment controller will. Yo, what's up, Smack GDs? It goes... yeah, it's going pretty good. Yeah, and instead of doing this, we do... we rely on our environment controller dot terrain. So I just have to take one step back and think about this one. Do I like this layout? So environment controller. Environment controller. Singleton holds the terrain, the weather, and a terrain fluid solver. Like when I think about the fluid solver, it feels more natural for it to be, or I would like it more if it were just a static class, so like helper functions, and then we call that one, like it's pretty much just logic. Given a start point, it computes a lot of things. But the only reason that I don't have it like that is because we need some setup, basically. We need a lot of different variables or constants that pretty much specifies the cost of traversing water. This will work for now. Terrain base as well. Might also work better as a non-monobehavior class later on. Terrain fluid solver, and these are the variables for now I'm talking about. We're gonna get a lot more of those later on. Yeah, we definitely want to alter them as well. Okay, let's see here. So, action terraform. Apply terraform brush. Alter terrain data. Right now we have it like this. Not very pretty, but yeah. So instead of doing fluid solver dot instance, so fluid solver was previously a singleton in of itself, but now we're gonna do environment controller terrain fluid solver add fluid terrain patch start this. when I think about it. So oops. Yeah, we're probably gonna make this into a static class in the end and just hard code the values of these. Because these, like when we have found the correct values for these, they're not gonna change anymore. This is just it's nice to have them available in the editor like this, so we can change them, experiment with them. But in the end, no. Okay, let's see what we have now. I'm skeptical of how it will work. Or if we might get a crash. But let's see. And it's water we want to add, yes. Let's see. Worst case scenario, we're gonna have to restart Unity, but I think it's okay. Okay, object reference not set. Terrain fluid solver 20. Okay, yes. I don't even know. Yeah, this is just... Yeah, we don't need this one anymore. Instead we do this. Okay. Okay. Do we get anything here? Greetings, Ibis the human. What do we have? Starting terraform. Terrain patch terraformer creation complete. Oh, terrain fluid solver step 1 done. In 2 seconds. Right. Step 2 done, step 3 done. Then we do this one, then we do this one. 2 seconds. Do we actually... No, it's definitely not 2 seconds, that's for sure. Yeah, what's up, GameX Hunter? The turn rate is a little bit snappy, but that's understandable in the early model animation. Plus, if you animate it a lot, the camera turn may take slower to catch up. I'm actually of the... I think it's too slow, the turn rate of the character. I'm actually... gonna make it more snappy. Okay, I'm very interested in what's happening here. First of all, terrain fluid solver step 1 done. 0.5 seconds. Is that really half a second for this one? That's not good. But makes no sense. Terrain patch terraformer creation complete, or actually starting terraform. Then we do this one. Then we do this one. The fuck? Ooh, 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 ooh. I wonder. Yeah, we just restart this one here. That's not good. We do start here though. I wonder if we want to do restart. But the fact that we're not getting any visualizations is also bothering me a bit. But yeah. Water. Okay, step 1 done. What is this? 26 milliseconds. It makes a bit more sense. But we're not getting a result. Or we're not getting any visualizations of the result, at least. If the animations and generations is perfectly good and smooth, you can make it faster, but if not, you're getting a glitch patch in the future. Yeah, right now we have a very basic animator in place. We pretty much only have idle, walk, run, and jump, fall, land. Those are the only animations we have. So there's really not that much to work with when it comes to turning and such. We don't have any specific turn animations or stop animations. That's for future polish. Terrain Fluid Solver step 1 done. 26 milliseconds seems about right, but why the fuck don't we get any visualization of this? If we go to environment and we do terrain base, terrain data visualizers empty. So where lies the problem? Spread fluid to neighbor. We do set data here. Water temporary and fluid. P fluid cost. Oh, get data. Yes. Okay, I know. Also explains the very quick timing for this one. We never add this fluid amount to the initial point. So this one has a fluid amount of 0. So when we do spread fluid to neighbor, we get P fluid here. Water temporary is 0. So we will always get 0 or less here. N fluid is 0, so this one will always be false, and we won't continue. So basically the 26 milliseconds here, what are we doing? Getting fluid, instantiating a list, restarting the stopwatch. We go through piece neighbors, so all of this, but this one never returns true, so we do this, and then this and this. and then we're done. 26 milliseconds. GameX Hunter, animations that is related to any action that is not related to movement, like putting something down maybe. Not entirely sure what you mean, but I'm listening. So yeah, what we need to do first here is we need to actually set the initial temporary water. That's for show, and we're gonna do it here. So we get the height, we get the fluid amount. Not entirely sure about this one just yet. If we want to do height plus fluid amount, but why not? So spread fluid to neighbor. Yeah, we just want to do this one. But terrain patch start. Set data, water temporary. Okay, there we go. Now we might get a crash. We'll see, we'll see. Love this. 255, yes, we need to alter that one. I wonder. Still only get one fluid point, okay. Okay. Yeah, okay. Let's see here. Yeah, pretty sure we don't want to do this. Let's see. So what happens now is that we get fluid here. We do... I want to try what happens if we add the water amount here. Okay. GameX Hunter, you have an inventory system in the game, right? When you check your inventory, you put your hands in front of your face, like looking at a pocket dimension kind of animations. We don't have... The idea is to have an inventory system in place, but it's not fully implemented just yet. And yeah, when we check the inventory in this game, I think we're gonna have check your bag type of animation, you know. But that's... we're not quite there just yet. So, this has been a recurring question. Water amount, should it represent fluid surface or actual water amount? Starting to think the latter. But we still have two issues, so let's go with the latter. So we remove height from it. Water temporary and fluid, yes. So we do a fluid amount here. Value float. Yes, we can do it with float. So let's just do fluid amount there. Skip this one. We set the data. And then we start. What's temporary? Okay, so the two other problems we have, the visualization of it fails tremendously, and we don't get any spread as of now. I want to double check the visualization first, and if we jump to get data, so get data returns a byte, so we're gonna have a value between 0 and 255. When we visualize this one, we want to do we get data here and we put it in value. I don't think we can do it quite like that, so we're gonna have to do mathf.inverse lerp. Zero 255. I wonder if I want Yeah, when we instantiate it, we need to instantiate it in the correct place as well. And I think we're gonna do it like this. So, terrain fluid solver, or actually, fluid solver. What do we do here? Prefab position, we need to calculate the position. Yeah, we need to do those two things. So I wonder... Instantiate this one at position terrain patch dot position world space. X Y, but we do IJ, and then so now it should be visualized at the correct position with the correct scale. So let's see if we still have a problem with spread. Also, one more thing, I wonder... Fluid amount is float, set data, do we have float value? Yeah, we do an inverse lerp here because we might try to set a value that is bigger than 1, and we want to clamp it at 255. Okay, let's see what we have. should be okay. Although I wonder... We're not getting any visualizers because value is 0 for all of them. Okay, here we're getting float value now. That's true. That should be okay still. Get data float, inverse lerp. Yes, get data here. This one we want to change to value, that's for sure. But still... We set data, fluid amount is a float, so the method we should be calling is this one, apply is false. That's good. Still, given what we have, yeah, maybe we don't continue walking through this one right now. That's okay. But we explicitly set the water temporary value at X start and Y start. So we should at least spawn one visualizer with this fluid amount, but we do not. Let's just try this. Okay, so that works. All values are 0. Do we want to throw this to an integer? Is that it? We get a byte. But I wonder, let's see, fluid point byte. That's pretty much how we did it here, I think. Or actually, no. Height int, yeah, we cast it to an int. And we're always working with ints here. That is true. Could that be it? Wonder. Yeah, maybe we don't even need that one. I wonder. Gabex, what's up? And thank you for the follow, appreciate it. Let's just double check this one. Would suck if this is the case. I find it very weird. Like, the first step we actually do is we add data, and here we read it. We should be spawning something at least. Bro, why are you not using Notepad++? VS Code is for casual players. Yeah, I'm a casual. Okay, so that's not it. What timing do we have? Step 1, it's extremely quick. I don't know. What are you doing right now? We're rewriting a fluid solver for this game. So the idea is that we will be able to add fluid at certain points in the terrain, but to do so we need to solve it, like where will the fluid end up and things like that. And we have a solution for this, we're just rewriting it now. Make it quicker, make it cleaner. Nighton, by the way, thank you for the follow, appreciate it. But right now there seems to be a problem with adding water at all. Like, we're not getting any change whatsoever. A little bit worried about this one. I wonder. Fluid solver. When we call terrain patch start set data, we do it with a float, right? Whoa. Yeah, we don't want to do an inverse lerp here. We want to do a lerp. Yeah, Gabex, if you have any suggestions, just shoot. It's a pretty complicated system right now, though. So we definitely don't want to do inverse lerp here, we want to do lerp, but we still want to clamp it, so like value here can be greater than 1, and if we wouldn't do a lerp here, we would be getting a overflow, I suppose. Fuck, I'm a little bit worried about this one though. Let's see here. This one gives us a float between 0 and 255, and then we just cast it to a byte. Can we do it like this? Hopefully. So previously we did inverse lerp here. I just have to double check so that the error we got makes any sense. Inverse lerp 0 to 55 value. Value was always between 0 and 1. So yeah, we would be getting 0 at all times, yeah. You like Unity? Yes, I do. Yeah, it's a very nice engine, I think. Okay, there we go. Beautiful. Now we have a start point at least. So we actually added data here. This is great. Okay, that's beautiful. Now to the next question. Why don't we get a flow from this? And that will probably be a bit harder. Gabex, I also like random warning and errors as soon as I create a new blank project. Who doesn't? Who doesn't? So let's see. Terrain fluid solver. What's up, Victor? Hope you had a wonderful stream, man. And thank you for the raid. Appreciate it. Okay, so add fluid here. We don't get any disperse of the water. So, why not? We set the data. Unvisited points count is bigger than 0. Take the first one. Saw a bit of the project in play before raiding, looked cool, so I figured I'd drop in. Thank you, appreciate it. And thank you for the follow as well. I wonder if this is what screws us. Spread fluid to neighbor. Maybe. we never... Or... Yeah, this one probably fails. Or returns false. Let's see. We get data P fluid, N fluid. Both are byte. It should be okay. Ooh. P fluid. Fuck. We want to do PX, PY. N fluid, we want to do N, N, N. I wonder... Yeah, that screwed us, definitely. So now those two are correct. Height difference. We calculate cost, we do P fluid minus cost, that's N fluid now, new I mean. Yeah, okay, let's try this. No problem, I do lurk now, appreciate it, appreciate the lurk. It's 10 hours, man, that's pretty hardcore. What's up, Bet Me? Appreciate it as well. Okay, we still only get one here. Interesting. Height difference. P height, P, PX, PY, N height, N, NX and Y. A little bit worried about this and this. Do we enter this one? Question mark. Forget. Let's just write some debugs here, so see where we're at. Oh, actually, got neighbor terrain point, spread fluid to neighbor success, add minima point. Do we get a lot of successes here? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. We get one for each neighbor. We also get add minima point. Very interested in this one. What do we have? Height 31, 32, 31. Yeah, this is a minima. But oh, I want to add. Yeah, we want to show some more stuff on this information right here. I wonder. So we actually, spread is successful, but we don't actually get any spread, would be my guess. So let's do this. First of all, terrain patch. Get data information, foliage. Unused 1A. Unused 1B. Okay. This one is successful. We get success. Let's see, spread fluid to neighbor. It only returns true after we've done this one. n.terrainpatch.terrain data set data water temporary n fluid. It's an integer. Set data. So this one, what do? We do clamp. Between 0 and 255. I think that's about right. Although let's see. Yo, what's up, E-Dragon? Now we should have more information, yeah. Unused 1A 255. Is that so? Okay. Yeah, whatever. Water temporary 0. Water temporary 25, 0.1. Yeah, makes sense. Water temporary 0. Doesn't seem like we're getting a spread. 51, 76, 2. Spread fluid to neighbor, success, but we don't actually add it. So something with the addition is wrong. Weird. What's on today's agenda? On today's agenda is still cleaning up and improving the fluid solver we have. I think I only streamed, or I only worked on it for like 2 hours last week. Not a very productive week. I find this extremely weird. Spread fluid to neighbor. We get these prints multiple times. Ooh, unvisited points append. Yes. Yes. I guess we need to do this. That's one thing, but still. Still. We still do this, so we should be getting some values. Right? N fluid new is bigger than N fluid. Yeah. Okay, so this is why we didn't continue, but still we should be visualizing these as well, unless cost base, cost up 1, cost base 0. Yeah, that's rough. One sec. Yeah, that's one thing I was afraid could happen, but I have no idea why it would happen in this case. Unvisited points count bigger than 0. Here we append if this one returns true. This one seems to return true most of the time. Okay, let's do this for now. This is what we want to do, but we can't do it unless this one is... we have fully figured out what is wrong with this one. Cost base, if height difference is bigger than 0, we're going downwards. If height difference is... if height difference is less than 0, then we do minus here. So cost will become... cost up is 1. So we get a negative cost here, which means that we will add here... yes. Okay. But we could just do this, I guess. I'll double check this one. $255, 0. Spread fluid to neighbors, success, but we don't get any fluid there. So that's what I want to dive into a little bit deeper. But before I do that, I need to run AFK real quick. Just grab something small to eat. So be right back a couple of minutes. Okay, back. Let's see. So yeah, once again, we have spread fluid to neighbor success, but we don't actually get any fluid here, which is weird. And we know that set data like this works. Because that's what we do here. But here we do it with float. That's true. That is true. So we do a lerp here. Yo, what's up, Desai? Good morning, good morning. They should lead to the same result. Whoa. And I probably this one, right? There we go. That makes sense. So the adding always succeeded, but then we actually just set the same value again. Oh well. There we go. And yeah, we don't get any further than this because we don't add any more to the list. We're going to, but I'm just a little bit afraid that we might get a forever loop again. So we need to alter environment, base cost 1, cost up cost up multiplied by height difference, base cost. Okay, let's go. If we do this, so cost 10, and then we get a little bit of a difference. That's good. 20. Okay, great. Yeah, we're gonna try this one. Might get stuck in a forever loop again, but let's see. Base cost 10, cost up is 1. We probably want to rename this one to multiplier as well. Finding minimums cost up multiplier. Float. We do the same with this one. 10, 1, yeah. I forgot to change one thing, the most important thing, and that's this one. So if we succeed in spreading fluid, we want to add it to unvisited points, but only if it doesn't already contain it. Let's try. Nice. Not too... Step 1, 0.15 seconds. It's quite rough, but that's okay. Okay, this one seems to be a little bit more rough. There we go. Way rougher. It's probably the print that takes too much time. We're gonna remove that one as well, definitely. Okay, great. Looks good. Although I wonder... 76, 34... Water temporary 76 here. 1. Cost base should be 10. So we shouldn't really have... We shouldn't be getting... Definitely not be getting more than 1 with 7. Depends. Yeah, if we move downwards, we don't have a cost to it. So 121. Yeah, here 76. Yeah, okay, so we move downwards here. Yeah, definitely want to fix that cost down multiplier. We want to be nice with that one. Let's see here. If height difference is bigger than 0, we're moving downwards. Okay. So cost down multiplied by height difference. But the question is, how would I actually like to handle this one? Cost down having it cost more the further down we go doesn't feel... I don't know, doesn't feel that good. I don't know if... We're probably gonna do this. Let's keep it like this for now. Cost down is 0, so we pretty much only get a base cost for moving downwards, so I think that's good. And let's also remove this one. And let's see what kind of value we get here. Or timing. Still pretty rough, I would say. Definitely. .6. Nah, something is definitely wrong. Base cost 10, cost up multiplier 1. Step 1, 1 minute and 40 seconds. I don't know about that. The result is good. Ish. What the fuck is wrong with the time? Get data shouldn't be costly. We're probably revisiting nodes multiple times. Get index wrapped, get terrain patch. Could it be... Unvisited points. Depending on the costs we have, we might want to revisit points. But I'm still very skeptical towards that concept. If we always follow the greatest water amount, yeah, I wonder if we want to do... I wonder what would happen if we did... this. So we figure out the neighbor. If that neighbor is already in unvisited points, we just skip or continue with the loop. Apart from that, I really wonder about the performance of this one right here. If a list might just be the better option. Or worst case scenario, I'm also wondering about this one actually. It's incredibly slow. Extremely slow. But then again, let's see here. Yo, what's up, JD? I've been good. Haven't had that much time to stream and develop the game though. But other than that, I've been good. How about you? Nah, the performance of this one is insane, and I have no idea why. Like, this is magnitudes slower than the other solution. Magnitudes. Let's take a look. "49 seconds. What the fuck?" That's insane. Yeah, something is wrong. Very wrong. Yo, what's up, Redstone? Long time no see indeed. JD been good. Nice to hear, nice to hear. How's the game coming along? Slowly, but at least it's coming along. Okay, so something is very wrong here. And I don't know what. I wonder if it's this shit. I want to... I hope it is. This one might... Yeah, this one. Definitely. Let's see here. First... And then we do unvisited points. Actually, unvisited points dot remove at 0. Unvisited points dot add n. And here then we do unvisited points order by descending dot to list. I'm a little bit afraid that this one, but I can't imagine this one being the culprit for the speed, and I'm also a little bit scared of this one being it. Like if introducing a custom-made class might be the way to go. I don't know. JD, what are you working on? We're working on the fluid solver, making it more performant and preparing the flow of it so we can animate it in a nice way. That's basically what we're doing. Redstone, how are you? I'm good. Got some sickness going on, but it's mostly fine. How about you? Okay, let's see if this list improves the performance in any way. Hopefully. Hopefully. Okay, that's quicker. Jesus. Are you kidding me? Okay, great. Okay, we're talking about 0.13 seconds for... Let's see here. I want to clear all of this. Okay, so if I add maximum amount of water at this point, what do we get? If I add maximum amount of water, we're looking at 0.1 seconds. That is beautiful. So adding maximum amount of water, finding where the water will pool up, takes 0.1 second. That's very nice. And if we hide that on a secondary thread as well, like we don't like hiding it with animation, extremely easy. But we're only 1/3 done, I think. But 0.1 second, that's good. The freeze we get, let's see here, 0.23 seconds for this one. It's still okay, I think. And the freeze we get is actually related to the spawning of multiple new objects, and we don't time that. 0.26, still okay, still okay. I wonder, okay, so given this information, 0.20, nah, we still don't have enough information to make any conclusions of how long time the full algorithm will take, so I'm gonna wait with that one a little bit, but let's see here. Yeah, 0.13 for this one. .37 for this one. Now that's pretty rough, but I guess it makes sense. Okay, thinking about it, like how best case scenario I think of how I would like this to work is something of a hose solution, I think. So the player selects a spot and starts adding water to that spot, and I wonder, probably the longer the player goes, the more water we will add. So this algorithm is we're probably gonna create a second thread. That one will do the work for if we added 0.1 amount of water. And then when that's done, we visualize the result for the player. If he or she continues to spray water, we do a second iteration, this time with 0.2, or actually just 0.1 again, I guess. Yeah. Mm. Okay, so step 1 done. Okay, step 2 is a bit more complicated. Unvisited points, final points. Minimas ordered by descending, finding minimas fluid amount. And then we go through all the minimas. Invalid endnodes. Yeah, probably gonna invalid endnodes. Let's see here. Yeah, this time I want to go through this one without introducing more lists, not introducing custom classes. So okay, so what do we actually do here? Yeah, the hard part here is going to be, we also want to prep, or we want to implement this algorithm in such a way that we can add fluid or water to a place that already has water. So calculate non-overflow fluid amount per minima. Yeah, we can do a lot of improvements on this pass, I would say. Although invalid endnodes.count is equal to 0. Invalid nodes does not contain n. So this one is unnecessary. This one as well, I would say. Yeah, this whole thing is extremely unnecessary. I guess, though, unvisited nodes. We clear it. Invalid endnodes add, and then we break. So we break this one. Yeah, we continue with this one. That makes no sense. We break this one. So we go to this one and we do these things. And then we go to this one. Since we have added one here, it means that this one is not true anymore, and we break this one as well. So what the fuck were I thinking here? I mean, it works, but there's a few unnecessary steps, I think. We will see. But I wonder, we're gonna have to do some more complicated stuff here as well. So this whole solution relies on custom classes that made things a bit easier while we were experimenting. And this is the final, this is like 1.0, the solution to 1.0. Now we just want to clean it up and make it faster and make it work with our the data structures we have, i.e. terrain data container. One sec. Back, sorry about that. So the idea is that our texture contains these channels, and for each step in the algorithm we want to add to water temporary, but between each step we want to move this data somewhere. And we also want to do this. Yeah, it's gonna be a mess, but so what I'm getting at, what I think we want to do, yo, what's up, Robert Pattinson? How are you and who are you? Well, as for the first question, I'm good. I'm good. Thank you for asking. How about you? I don't know how. Water previous. Yeah, I'm pretty sure we want to take water temporary and we want to move it to water. I guess that's how we want to do it. we take water temporary, we move it to water. Yeah, that's what we want to do. And then we want to work with water temporary again. So basically, but then again, because the idea is, together with the timestamp, different states of the water, we can animate this pretty nice in just a shader alone, or that is the end goal. I'm still skeptical if we will be able to solve it, but maybe. I made a thingy, but I won't show you. Well, because it's not really special and showable. Yeah, I'm extremely curious about it. Okay, I don't want to put too much time on this right now, because it's going to be subject to change a lot. But what I would like to do is, I would like to implement a method or a way to move data from one channel to another very quickly. I don't think we have any methods for that by default, and the quickest way would probably be to do it on the GPU with some shader magic. Let's see. Or could we actually find a P could probably manage to do it in a nice way here. Oh, could we? No. Okay. Could we actually do something like this? I wonder. But I guess, yeah, when we switch here... maybe. Robert Pattinson, I use Godot, by the way, and I hate it. What do you hate about it? And once again, I've only worked with it, in it, for like 4 hours, so I don't really have a... the fuck is the word I'm looking for? I don't have a opinion about it, but would love to know why you hate it. I wonder when we do this, I want to double check this. I wonder if we can do some hack with this one. Probably not. And what texture formats do we have? Let's see here. 32. RGBA 32, BGRA 32, ARGB. RGBA, ARGB. This one just switches the A and R. It switches all 1 steps to the right, pretty much. BGRA. Do we have... Yeah, I guess we could do... We could do it like this if we had every combination available. But then again, convert texture. Copies the pixel data from one texture, converts the data into different format. Copies Yeah, we're probably gonna have to create our own method for this. Like, even if we did this one, I guess if we go from RGBA 32 to, I don't know, ARGB 32, it will probably fix the channels as well. We don't want to do that. But what would happen if one simply... Nah, we can't do that. Okay. We're gonna have to create a... We're gonna create a custom shader that reads from one texture and puts it in another texture channel wise, pretty much. It's probably going to be quite costly to do. We can implement two methods for it. We can implement one that does it on the GPU and one that does it on the CPU. And it all depends, like currently we only work with the data on the CPU. So I wonder which one would be quicker. Go through the full texture on the CPU and switch each color pixel wise, or do it in a shader. The bad thing with the second option is that we're going to have to send the data to the GPU, do the calculations on the GPU, and then we're going to have to read the result back, which is costly as fuck. But yeah, probably going to implement both, see which one performs the best and go with that one, because I think we're gonna have multiple different cases here where sometimes we also want it on the GPU, so we need to send it there either way. So yeah, let's implement both of those approaches and then see. Okay, Robert Pattinson, let's see. They say it's easy to use a noob-friendly engine. Feature. Childish logo. Yeah, a lot of what you say is what I felt. So I believe you. I take your word for it. I'm mostly sad that like GD script is the default, if you know what I mean, or the main language you program in. So Robert Pattinson, when are you switching back to Unity? Terrain data container. What I would like to have here then is a method like apply data, alter terrain data blit, instantiate data as render texture, set terrain. Let's see here. Alter terrain data blit. So we're gonna have a method like here, I think. Public void whistle. That's not swap data. And we're gonna have terrain data type A, and terrain data type B. And then we're also going to have one void swap data terrain data type A, type B. And this second one we're also going to name blit. So swap data on swap data on CPU, swap data on GPU. That implies that we only do it on the CPU or only on the GPU. Swap data blit. Probably the correct. Yeah, let's go with these. JDScript sucks. Yeah, that's pretty much what I got from reading the tutorials and stuff like that. Like, why? Why go with JDScript instead of just C#, for instance? And also, community is basically a cult. Yeah, but that can be positive as well, right? But yeah, I would continue to use Unity if it wasn't loading empty project for 5 minutes. Is it that slow, really? Okay, so swap data blit. So here we can do... Fuck, how do I want to do this? We want to get the data array. Color32 struct, so we're gonna have to recreate them. That sucks. Native array color32. Do we have to rely on color32? I wonder. Pixel data. A native array that points directly to the textures data buffer in CPU memory. Can we define T ourselves? Yes, we can, but I wonder if... Can we go crazy? Can we go class? Can we go reference type? You usually use a struct for t that matches the structure of pixel in texture, for example called You usually use a struct for t that matches the structure of pixel in texture. I guess we can do this then. Yeah, it also depends on if type A and type B are in the same texture. If they are in the same texture, it's probably a little bit easier. If we could hard code it as well, I wonder. This, okay. We can get them, but I don't think we can set them. So for instance, get data, type A, 0, 0. That actually just gives us a byte, but if we did get data array type A, and then we do 0. So we get a color 32, and then we do 0. That works. Now we can do but doing get data array type A 0 0 is equal to 0. Yeah. But okay, we can get the values like this. Can we? So we probably want to do type A, let's see here, native array, color 32, type array type A. Okay, so these two might or might not point to the same data. Either way, they should have the same size. So we're gonna, just to make sure, we're gonna do this. Or actually, yo, what's up, Little Miss Murder? I hear you, I hear you. Makes me wonder if this one is probably much easier, but data's render texture. The focus group has convened and determined that you have a non-zero number of bugs in your project. I'm not surprised. Ooh, that is true. If we want to change... Actually, swap data. Do I want to support... Do I want to support swapping data between the textures? Probably do. But we're gonna have to handle it differently. I just discovered a big bug in code I wrote in 2009. Damn. Security risk? Question mark. Yes, potentially. Shit. Robert Pattinson, wow, I wasn't even born. The fuck? Are you seriously born after 2009? That is insane. It's a biometrics fingerprint matching cluster. Biometric fingerprint matching in 2009. Damn. Yeah, you had me worried for a sec, Robert Pattinson. But I wouldn't be surprised. 2009. Swap data. If we swap channels in one and the same texture, it's much easier. If we swap between two different textures, it's going to be a little bit more complicated, I think. Yeah, 15, I suppose. How would I even do a swap blit? A swap data blit between two different textures. Can we do it in one blit? Probably. No, I don't think we can. My data files start with a 32-bit record count header and are suffixed by a 32-bit CRC. So record count was 0 and the CRC32 used a seed of 0. So the checksums checked out. Damn, crazy. I have no idea what the NAS malfunction is though. Network detached storage. Someone must have done this. Switch to color channels. Texture Unity. Or actually swap. Can't you just AND 2-bit shifted ARGB values together? Maybe we can. I like the sound of it. I like the sound of it. I'm listening. So we have a few different cases here. One case is something similar to, we have one texture A and we want to switch the red and the blue channel with each other. The other case is, or like case 1 is we have texture A and we want to switch channel X with channel Y. The other case is we have a texture A and a texture B and we want to switch texture A channel X with texture B channel Y. Or it could be texture A channel X with texture B channel X. And we're working with RGB A32. And then also, if we want to do it on the GPU, we're going to have to move data to render texture, then we're going to do a blit. Actually, we just, yeah, if they are in the same channel, it's going to be very easy to do on the GPU. Fuck, let's do the GPU one first, but we're probably going to have to do this. If get data texture type A is equal to get data texture type B, else. Like, we can probably do it like this. Terraform shader. I wonder if we can do it. You could probably also do an additive blit of two inverted images. But I mean, if we're doing... If it's the same texture we're doing it for, then it's way easier, I think. Let's see. I wonder if we could just do it like... We're gonna have to send in some information. Or... Let's see here. So if we do a custom shader, a custom functional shader, and a custom material, it would be pretty straightforward. I wonder if... But the question is, can we hack it in some other way? Yeah, probably just gonna assume that they have the same scale and offset. Should be okay. Channel swap shader. Let's see here. A little bit worried about that one. Or is it just... I don't know. One or 0, 1. This is blend 1, 0 we want. Yes, yes. We don't care about this one. And then you could do float for final color is equal to color. Can you do channel A is equal to question mark? How about function swap RB channel? Color, return color. Oh, yeah. Like, if we knew which channels we would be swapping, then we would just swizzle it. It would be amazing. Although I want to implement this in such a way that we can go crazy with it. I want to make it, like, generic, you know? On the CPU, though, it's the old problem of switching two variables without introducing a new variable. Blue Horse, by the way, thank you for the follow. And yeah, unfortunately I gotta run now, but we're gonna continue with this tomorrow because I need these swap methods, and I need both one on the CPU and one on the GPU. So we're gonna implement those, test them, and then we can continue with optimizing the fluid solver. Interesting times. But yeah, I will be back tomorrow with another stream. Continue this. Sorry for the abrupt ending, but have a great rest of the day. Peace.